Okay, we'll do the 15th question. This is on page 29, right? So it says a competitor runs in a straight line, passing 3 points P, Q, R, right? And they have given the distance of PQ as 2.4 kilometers, right? 2.5 kilometers, 2.2 kilometers, and QR 11.5 kilometers. And also, the computer takes 1 hour to travel from P to Q. That also I have put. And the computer takes 1.5 hours to go from Q to R. That also I have put on the diagram. And throughout the motion from PQR, the competitor maintains a constant acceleration A. I have put A here. Part A, what they want is the acceleration, right? And part B, what they want is the velocity, which velocity at V. So we will put here, maybe here V1, right? Here V2 and V3. So there are three different velocities. So what they want is V1, right? Part A we will see how to approach, right? Now, if you consider the PQ section, right? If you consider PQ section and if you apply S equal ut plus half at square, right? Just give me a minute. Right, so if we apply S equal ut half at square from P to Q, V1 will get involved and acceleration also, I mean initial is V1 and acceleration also will get involved. Those are the only two unknowns, t and distance we know. And also again if we apply S equal ut from P to R, right, again initial will be V1 and the unknown only thing is the acceleration. Time we can find the total time from here and also the total distance. Then we get two equations, right? Two equations with V1 and A unknown. So we can solve those simultaneous equations and find the acceleration and the initial velocity V1. So we will do that. Part A we will start. Part A, so we will write S equal ut plus half at square from, we'll say P to Q. P to Q, and the positive direction will mention to the right side. So what would be the displacement? 2.4 equal initial velocity will be V1 and the time will be 1 hour. 1 hour. So S equal ut plus half A and 1 square. So finally we will get 2.4 is equal to V1 V1 plus A over 2. A over 2. We'll label this as capital A. Now again we will apply S equal ut plus half at square, right, from P to R. P to R, and positive direction we will consider again right side. Then P to R, the total distance will be 2.4. We'll add it and put then 2.4 means 13.9, 13.9, right, is equal to again initial velocity. Although this is a different section, still the initial velocity is V1, right, V1, and it takes a time of 2.5 ut, right, ut plus half A is unknown, again 2.5 whole thing square. Then we will 13.5, 13.9 is equal to 2.5 V1 plus 2.5 whole thing square over 2A. We will make this as capital B. right? And now you would see these two simultaneous equations. From this simultaneous equations, if we eliminate the v1, we will be able to find the a. So that is part A, right? Then what we will do is right. So how to do that? Form capital B, right? Here this is 2.5. So capital A, right? Capital A into 2.5 minus capital B, right? So capital A. Then we will get 2.4, right? 2.4 into 2.5, right? That part comes to LHS minus 13.9 equals to this V1 part, it get cancelled out. 2.5 V1 minus 2.5 V1, they cancel. Here we get 2.5 over 2, that is the coefficient of A, and here we will get minus 2.5 over 2 minus 2.5 over 2 whole square over 2 and into this is as the coefficient and A. Okay. Now we will see, I will put these values to the calculator and then I will put an answer here. I will pause the video and do that. Right, so here for LHS we get minus 79 over 10, right? I will multiply this as subtraction, and also this coefficient of A, when you simplify you will get minus 15 over 8, and when you cross multiply and bring it to the other side, A will be 79 into 8 to 150, and this we can divide it by 2, then this will become 75 and 4, right? And I put this in the calculator, it gave 4.21, right? So that is part A, right? And remember this is kilometers per hour square, right? Because not seconds and meters, everything is, the units are different, that you have to be careful. And part B, what you have to do is get this value. Now remember, when you are putting this value into the equation, one of the equation A or B, you have to substitute and find V1. So this capital A is easy, but remember, don't put this decimal value, put this whole number and make V1 as the subject and get the answer, and you can keep it for 3SF. Right, so I won't do that part, it's very easy, right? It's like a grade 8 question now. Right, we will now attend the 11th question, which is on page 28, right? It says a particle is moving along the x-axis. So I have drawn the x-axis, right? X-axis, and the x-axis. On the x-axis with constant deceleration 5 meters per second square. That I have put as a deceleration, right? And at time t equals 0, the particle passes through the origin. T equals 0. So when t equals 0, it is at the origin, right? O, right? With the velocity 12 meters per second in the positive direction. So in the positive direction, so I mean no need to mark the positive direction because this is the x-axis, and the x-axis positive direction is right side, so no need of labeling the positive direction here, right? Then it says at time t seconds, the particle passes to the point A. We have to label this as A, right? A. This is A, right? This is O, T equals 0, right? Coordinate and maybe O also 0, also whatever, right? Then particle coordinate 8. So 8 units it has gone there. Then the part A, what they want is the value of T. So we will try to find that. We will see the part B, the speed of the particle as it passes through the point with x coordinate minus 8. So they are talking about another point, right? Another point minus 8. So surely this will, I mean, I note here he might pass this with v velocity. We say v1, right? v1, and then actually now according to the situation, right? According to the situation, right? This is decelerating, so we will slow down, right? Slow down, and we'll go back and it will pass the origin also. Now the trouble is maybe he will just touch here and go. Surely because they are asking the time, it is going to reach the particle, going to reach the A, because they are asking the time. We can't think of turning halfway. So either he will touch here and go back, or maybe it will pass and come back and goes from here, but definitely -8 is going to pass and forever it will go like this. So then we can put here v2, right? v2, and what they are asking is the speed of the particle. So v2 they want, and here if it is t, we can mention this as t dash, right? So some things are there and all the details are here. We will try to now tackle this. Right, to find t, right, now t we want nothing else, right, so if we take v equals u plus at, final velocity is going to get denoted, but if you take s equal ut plus half at square, only the time factor, those are getting involved. So we will I will use that. Other thing is that this also final velocity is getting involved. We can't use that. So we will use the second equation. We will put from O to A, right? O to A is equal to ut plus half at square, and we will make the positive direction to the right side, right? It's always positive, right? Anyway, we will apply this. Then the distance will be 8. The initial velocity will be 12 meters per second, right? 12 meters per second. 12, and the time, that is what we have to find. We will put a plus half. Acceleration, actually it is opposite, I mean it is decelerating, so we have to put -5 here, and t square. So we get a quadratic equation. Now this is going to be 2.5, I will bring this to this at 2.5 t square minus 12t minus 12t, then plus 8 is equal to 0, and if you multiply by 2 we will get 5 t square minus 24t plus 8 equals 0. So if we see the factors, definitely 5 and 1 we have to take 4 into 2, 1 into 8. I'll check the answer. Right, so here it is 16. We can put here 4, then we get 24, 20 and 24. So the minus we can put here. We get 5t, right? 5t minus 4. Or t minus 4, and now we get actually two answers. The reason is he doesn't actually stops here and returns. He passes that and comes back. So we'll just check the question, and particle passes through the point A. Yeah, so we can leave both answers. Part A, t is equal to 0.8, right? 0.8 seconds, or 4/5, 0.8 seconds, or t equals 4 seconds, right? So at those 2 points they are actually passing. Now part B, what we want is at what time is what speed he is going to pass the -8, right? -8. to do that, I will label this point as A dash, right? So this is a behind point. We will use the V squared over U squared because the distance we know, displacement we know, and the initial velocity we can actually put it from here to here. Right, so we'll put, I mean, I'm applying the V equals, now in this case you have to be a little careful, right? So I'm applying the V squared equal U squared plus 2As in the positive direction, and the section will be 0 to A dash. 0 to A dash. So actually when you consider direction 0 to A dash, right, he will go to this side and pass this point and then again come back. So that is the path, right? It is not the section which is going from here, right? So the final velocity we want to find, we will say v2 square. Initial velocity we will put as 12 square, so positive direction, plus the deceleration is minus 5 plus 2 minus 5, and the displacement, right, displacement, now we are applying the equation in the positive direction, but if you consider the origin to A dash, it is minus 8, so minus 8, then we get V2 as, right, 12 square plus 40, this is 10, 80, so plus 80, that is 144 plus 80, sorry, 80, and square root of that, right? So here we get actually plus or minus, right? So we will put like V square is equal to 144 plus 80, right? Plus 80, that is 224, right? 224. So V2 square, then V2 is equal to plus or minus square root 2 to 4, right? And then you have to take the V2 as the positive, V2 as the positive. We'll do like this, we will take V2 as the positive value, and then we will say therefore the speed is square, I mean we have to put the answer here, 224, right, meters per second. You will put this as to the right side, right? So choose the positive value. I mean here we have a little confusion now, because if it is, now this is a positive direction, he is going backward. So if you are talking about the velocity, it is going to be negative. But if it is, if you are going to talk about the speed is positive. But then it's a partial answer. So what you can say is, to be in the safe side, right? To be in the safe side, you will put the positive value and you mention the direction, and we'll see what they want. Also, the speed of the particle as it passes through the point with exponent minus 8. So even if you put the positive answer, because it's a speed, it can't be negative, right? That's also all right, but better just tell the direction also, right? Then we give the 11th question. Now we will do the 15th question, and after that I will repeat this a little difficult question. No, not the 15th, 14th. 14th is a difficult question, and after that we will go to the 2.6 vertical motion under gravity. So before that we will attempt the 14th question. Right, this is the question 14 in page 29, right? Now I have put the details which they have given in the question. This is a little difficult. I mean, to put onto a diagram, it was difficult. So I will first read out the things. Here it says two particles P and Q are moving in a straight line. So here the picture is when T equals 0, what was the situation? And when T equals 1, after 1 second, what was the situation? And after T seconds, what is the situation I have drawn. This is a general situation for both of the particles. This is the special case for when t is equal to 1, and again this is the beginning of the measuring of the time. When we started to measure the time, this was the picture we could see. So we'll see whether I have put all the data correctly. And it says P and Q are moving along the same horizontal line with constant acceleration 2 and 3.6. So acceleration double lines 2. This is P. Always P will have 2. P will have 2, and always Q will have 3.6. But in this one, Q is not in the scene. Now we'll see. At t equals 0, so this is the data which I have put for t equals 0, right? They have told t equals 0, P passes through a point A. P passes through a point A with speed 4 meters per second. 4 meters per second. Right, 4 meters per second, that I have put. So that's all they have given, and they are again telling you 1 second later. So that picture is here, and 1 second later. So 1 second later, surely this P should go forward a little bit, right? So if he goes forward, his acceleration, it should be double arrows. His acceleration is still same 2, and this 4 should change to another value. Right, to be precise, after 1 second, if it is 2 meters per second square, it should be 6 meters per second square. But I will put it anyway, some value is there. If you want to, we can put 6 meters per second, right? After 1 second, right? So if you want, we put maybe I will put it, right? So here it will always will leave as it will, and then more trouble, some velocity, right? So after 1 second, they say this yellow should go forward. After 1 second later, Q passes through point A. So he appears here with a speed of 3 meters per second, that I have put here, and his acceleration already given in the beginning, that I put. So always throughout the motion, this fellow's acceleration is 3.6 meters per. Right, with the speed 3, right. Moving in the same direction. Now he was going in the positive, this also now came into the scene. Right, now it says, write down the expression for the displacement of P, right, displacement of P, right, this is part A. P and Q, so displacement of P, displacement of Q, from A. So that the measure, displacement is measured from A. So that is why I have put here dq dp. Right, now they want expressions in terms of t. So those expressions should have t only. And we will see that. Right now the story is like this. Now here he has a low, he has gone forward and he is coming from behind, right, and he is having some velocity. Now the trouble is Q is having a higher acceleration, although he is behind, and he is having a low acceleration. So surely this Q is going to pass the P. Actually it is not shown in this general diagram. So for some t value he will come to the same position as the P, and after that he will overtake. So we will leave that, and we will try to now get the expression for dq and dp in terms of t. So before I proceed, I will introduce some more letters to handle this. Right, to handle this. So we will now, we have A here, right, we have A here. So after 1 second this fellow will go forward, I will make this one B, right, again after t seconds. So here we assume, we assume t is greater than 1, right, little bit later, right, t is greater than 1, right. So in this case, surely this fellow will go to a new place that we will mark as C, and after t seconds, now he was in A, he will go to another place, so we will make it this one D, right. So now we will apply expression of what now they are asking in terms of t only. So in terms of t only. So definitely this a, d, those things are there. Right, dq will be there. This one initial velocity we know and how much time and axis. So we have to use the second equation is equal to b. So we'll put right for a. Now this in this one for a, right, for a, I mean sorry, for p, capital P. Now you have to remember all this time, I mean when we started the section we just mentioned the section equation and the positive direction. Now in this case, because there are two particles, when you are applying the equation you have to mention the particle, you have to mention the equation, and you have to mention the direction, positive direction or whatever. So there are both things. For P we will say is equal ut plus half at squared, right, and section in half at squared, right, in the positive direction. This is the positive direction, and we will tell the section, right. Here we are going to apply for P the first fellow from A to C. A to C. So here 0th second he is here and the t second he has come here. So we have to say, right, for P this is the equation positive direction from, right, from A to C. So this is the heading. Now if you don't put these values, I mean we can't give marks if you just put numbers. So now if you take this section, how much P has gone, dP, that is what we want the expression, dP is equal, that is the displacement. Initial velocity when he was at A, right, it was 4 meters per second, 4. And how long he took to travel this AC distance from A to C, so that is the picture t, right, t seconds, t, that means ut plus half his acceleration, his P's acceleration is 2, right, 2 half a t squared. So we found the expression, that is 4t plus 2 will get cancelled off here and we get t square dp, right. So now one answer is alright, that is dp is equal to 4t square. Now we will try to find dq, right. So what would be the, I will do it here, I will do it here, right. Then what would be the section? So dq we are going to consider section A to D, right. Now A to D, right, we will say for Q, the particle is Q, the section is there, and the equation we are going to use is equal ut plus half at squared. And what is the direction? Positive direction is to the right side. Now A to D, how much this fellow has gone? dq, and what was his initial velocity? He passed A with 3 meters per second, 3 into how long, now this is a very tricky one, right, how long he took to travel from A to D. Q, actually Q comes into the scene when the time was 1 second, right. This is 0th second, so here 0th second, and if it is in the t second, for example, right, now 0th second this fellow comes here, 1 second, first sec, after 1 second he will come here, then after 7th second, if Q is here, 7th second, that means he took actually 6 seconds to go from A to D, 7 minus 1, because in the starting point already 1 second has gone, another 6 seconds. So here what we have to do is t minus 1, that is the difficult part, t minus 1, that is the time which Q took to travel from A to D, t minus 1 plus half, and his acceleration they have given 3.6 into again t minus 1 square, t minus 1 whole thing square, then dq is equal to, we'll say 3 Anyway, I will put the, simplify the answer, then you can do at home and see whether we are getting this. Okay, these equations were correct, and actually I checked from the answers, right? So answers, now we get a quadratic equation for, we can simplify a little bit of this, right? So we get a quadratic equation for dq, displacement of q, and also we get a quadratic equation for this, right? So that part A is right, and part B, find the value of the particles where the particles meet. Find the value of T where the particles meet. So that part B, how to approach, right? When they meet, right? When these two fellows meet, right? Because of this high acceleration, right? He is actually reducing the gap, and there will be a place where they meet. So at that point, the both displacements are going to be equal. So part B, what you should do is dq is equal to dp. Right? Make these two and then substitute the expressions you found. So, sorry, dp we will write first, dp dq. dp for t squared you put it here, and this expression also you put it here, and then you will get a quadratic equation, and find the solutions of that. Right? Find the solutions. So surely one value should be a negative answer, right? Maybe a negative answer, so only one value should be accepted. Please, now I did this much, 80% of the question I did, right? Maybe you all can attend this and let me know what happened for T, right? And also part C, it says find the distance of A from the point where the particle meet. So when you solve this, we will say we got T equals 12.3 seconds, right? Part C, what we have to find the distance of A from the particle where they meet. So either substitute this value to dq or dp, both should get a same answer. But if you look at the expression of dp, right, it is a very easy one. So for that you can put this value and find it. So I did the bulk or the most difficult part. Right, now hope you all will complete the rest and show me. Right, we will see what is we can do. I think we did enough from this section, and now we will move to the vertical motion under gravity. Okay, we will start the section 2.6, motion under gravity. We can say vertical motion under gravity, right? So, surely we are coming to the vertical motion, and this is the section 2.6, right? And it is in the page 29. So, only thing what you should know is now we did several examples and questions for the previous one. So it is in the motion under gravity also it is same. It will be using our equations, and also graphs will be involved, like the graphs, displacement time graphs, and acceleration time graphs, those things. Only thing vertical motion under gravity, this one always the gravity is downward, that you should remember. And also in the book it has taken as 9.81 meters per second square, right? So grade 8, 9, 10 normally we consider this one as GS 10, that is a rough value. So this is a little more accurate, but now you all have to check whether I can't remember properly. In the paper they will state, if they state 8.1 meters per second square, then you have to use this value, right? This value, and please when you get the paper, always in the instructions part, just see what value they have given, or in the equation part, right? Just see what value they have given. If it is 9.81, use that. If it is 9.8, use 9.8. Right, now I will do the example example 11, it is on page 30, right? Page 30, example 11. Page 30, example 11. Here it says the book falls off the top shelf of a bookcase. The shelf is 1.4 meters above a wooden floor. So remember, when you are drawing the diagrams, right, always no need to draw the bookshelf. Like this you should not draw. Right, always modeling is used, and even a book is falling, you model that as a particle. So what it says is the book falls on top shelf. So here falls. So surely the initial velocity should be 0. And the gravity acts downward, we say 9.8 meters per second square, right? This one. And this wooden floor, we don't care whether it's wooden or whatever, anyway it falls down, right? Wooden floor, right? Now it asks, now when he comes here, right, he will enter with the velocity v1, we don't know that, and also we will make t equals 0 in the beginning. And here we will say t equals t1. At that time we will reach here, and it says the height is 1.4 meters height, the bookshelf. Please remember, right? Please remember. Now, in mechanics, all the data which they are given in the question, you should label them, right? And don't try to take the details from the question and try to answer. It will be really a difficult, it will create difficult situations. It is not IELTS reading exam where you read a paragraph of some text and you answer. Always here when you get the paragraph, right, you put all the details onto the diagram, and then we don't even look at the description. After that we handle the question from the diagram. And also the diagram should, little by little you should make it perfect. It's not to decorate the question, right? It should help to solve the part A, part B questions, and by drawing this you will put some data here and there and in a rough way, and then but still you will be taking data from the paragraph. So that approach is not good. But beginning, because you are struggling or something, you can do that. But please try to make it perfect and put all the data onto the diagram. And if it works correctly, you should be able to handle the question by looking at the diagram, and you should see the story in the diagram. Like part A, now part A they asked, and we will put A, B also, these levels, right? Right. Part is the time, they are asking us to find the time the book takes to reach the flow. So actually they are asking T1. Right, now we will see what we can use. V equal U plus H, our basic problem. So initial velocity is 0, final, we can't use that. We don't know the final velocity, time taken. So we will use S equal ut plus half way. These are no other one, no. Time is only getting involved like this, and initial velocity we know. So this one and displacement are we know. So right, we can say now the heading, right, from A to B, S equal ut plus half AT squared downward. And so here also we should mention a direction. Then displacement is 1.4. So here when we consider A to B, right, that means the displacement is measured from this level A. Right, remember that. So from that it has gone into the positive direction. Then 1.4 is equal to initial velocity is 0 and t plus half 9.8 t square. Then we get t square is equal to actually I will take the answer from the book. 1.4, these are no need of the book, we can write them on 1.4, and this is going to be divided by 2. So 1.4 divided by, this is 4.2, 9 divided by 4.9, and that is equal 14 divided by 49, and again 7, 2 over 7, and take the square root, right? So t is equal to square root of 2 over 7. 2 over 7, and we can say since t is greater than t1 is greater than 0, you can't take the negative value. The answer will come to 0.53, 0.53, 3 SF. Second, 3 SF. Right. So part A we did. Now part B they are asking the speed with which the book strikes the floor. Then they are now focusing on the V. We have to find that. What are we going to do? Since we know the final answer, that's also alright. Final velocity V equal U plus. I will maybe I will use this. Right, because this is square root and lot of trouble is there. Now here final velocity V1 square, and here initial is 0, axis 9.1, so it might be easy. When the part B, I will use from A to B, right, is equal no, since we found this equation is better. Right, so we will from A to B, we will use S equal U plus T, right, U plus B over 2 into T, right, then downward, right, downward, positive direction. Then we get the distance is 1.4, displacement 1.4, initial velocity is 0, plus final is V1, that is what now we are going to find. Divide by 2 into right, we will put like this 2 over 7, right, root 2 over 7, then that error is not going to get affected, right? So V1 would be, then from here if we go here, V1 is equal to 2.8, right, 2.8 into 2.8 into root here 2 over 7, then 7 over 2. So V1 we will get as 5.2 meters per second. So we did the example 11. Now we will attempt the example 12 in page 31. Right? It says a ball is projected vertically up from a point X which is 7 meters above the ground. So we have the ground here. We can say this is the ground level, right? And there is a point from here where 7 meters up, right, up, and from that place he is projected up. So we'll mark a particle like this, and he goes. So finally he comes here and comes back and comes to the same level, right, and finally hits the ground. So this is the scenario. So projected at point X. So we can say this is X, right? So we will say X, Y, we'll say X and capital A, B, C, D, capital A, B, C. So those are the 3 points which I have got. Some extra things I have drawn, it's alright. So they are asking the greatest height above the ground. So now this is the greatest height and above the ground. What they want is this H, right, H. Part A they ask that, and the time of flight of the ball. So here time of flight means now we will put here t equal 0, he is here, and t equal 1, t equal t1, he comes here, and now this is projected up with the speed 21 meters per second. Here I will put 21 meters per second, and here I put the velocity is 0. He comes to the highest place, and surely because of the symmetry we know that it will go with 51 meters per second downward. Meters per second downward, and this one we don't know. We can say V1, right? V1. And now the trouble is, now here t equals 0, t equals t1. Actually here we can say t equals t2, and final t equals t3. Right? So the time of flight, remember, right? Time of flight means how long he was flying and how long he was airborne. Right? So here now he starts the journey here. Once as soon as he starts the journey, he is actually on air, right? Flying. So from up to here and until he hits the ground. So part B, actually they are asking T3. T3 they are asking, right? And part A they are asking H. So now we'll see how we are going to approach this. Part A, and I will mark the gravity. G is equal to 9.8 meters per second square. That also we will mark. Now part A, what we want is H. Right, H. Right, we'll see how we are going to attempt that. Right, so if we take all the equations, right, now we don't know how t1, we don't know, time we don't know, so definitely t, when all the equations which are getting involved t, we have to omit. So this is the only thing we can use, right? So here to find that one may be, right, H, maybe from x to a. X to a, we can put v equal u plus at, sorry, v squared equal u squared, but with the final velocity we know it's 0, and the initial we know it's 21, and acceleration h. So here we can write, instead of the displacement, h minus 7, then we can corner h, right? So we will apply first section from x to a. From x to a, right, we will use v squared equal u squared plus 2a's upward positive direction, right? And so final velocity is going to be 0. 0 is equal to 21 square plus 2. G is actually 9.8 now, because we are applying the equation upward, minus 9.8. And here the distance or the displacement is going to travel is from x to a, h minus 7, h minus 7, h minus 7. Or you can, if you really wanted, you should have, you can put here another h, simple h, and you can find that and add to 7. That's also alright, but I will take h minus 1, straight away we get the answer. Then we get right, 21 square. I will leave this one here and I will bring everything onto the other side, right? So 9.8 h minus 7 is equal to 21 square, and if here we can make 19.6, right? H minus 7 is equal to 21 square. Then if I take off the brackets, no, I will, we can divide it, right? So h minus 7 is equal to 21 square divided by 19.6, and h is equal to 7 plus 21 square over 19.6, right? We see the answer. So I checked on the book, the answer is right? It comes to 30 meters when you consider 2SF, 30 meters 2SF, right? That is all right. Now we see, what else we want to find. Okay, now we want to find T3, the time of flight, right? So here we can do okay, I will erase the part A and I will start part B. Right, part B, we will do like this. If you see, now if we use the is equal ut plus here from x to c, right? X to c, if we put s equal to ut plus half a to the time now we have to find out, that is the trouble. Time will get cornered, the acceleration we know, and we know actually how much is going down. Now this is a tricky situation. Since he started the journey, I mean upward, in this case I will consider the positive direction is up. I mean both ways you can consider, it gives the same answer. So I will put upward, right? S is equal to ut plus half a t square, right? From x to c, right? Now he will go to the maximum height and he will come back. So from, right, from, we put it here, from x to capital X to capital C, right? So now we have to be a little careful here. Now when he is going from X to C, how much he went upward? Now we are considering positive direction is up. X to C actually minus 7, the displacement is minus 7. This is the start, this is the end, and positive direction is up. So he has gone down, right, downward. So minus 7. Initial velocity, it is in the positive direction, so that is 21, right? And from x to c, how long he took? t3 plus half. When you consider positive direction, gravity is in the opposite, so again minus 9.8 and t3 square. So when you solve this, right, you will get a quadratic equation as 4.9, right, 4.9 t square minus 21t and minus 7. Please, although I put this arrow, you all please just see whether you all can simplify this, right? Right, equal to 0. And this one you have to use the, I mean two answers are given. I don't think we don't get factors. So use the equation or put into the calculator and get the answers. You will get two answers. T1, I mean T3 is equal to 4.59 something, and right, or T3 is equal to 0.310 something. Since T3 is greater than 0, right, greater than 0, you have to take the positive answer. So it becomes 4.6 seconds to SF. And here, right, now earlier I said, now we have to reject this negative value. But if you look at this, but this is just a discussion, right? This is a discussion. We are rejecting this, right? But see, I mean the equation thinks that whatever the conditions was there from x to c was there in the beginning, I mean before the start also. So that means 0.31 seconds. Now the particle, when the t is 0, he is here at the point x, and he is going from this direction, and he is under gravity, right, under gravity. So actually little bit before he should be I mean below this point, and the velocity should be greater and greater. So that means minus 3.1 also valid, but the trouble is no data. Maybe someone projected from this point initially from 21 meters per second, so that is the normal situation. But remember, these equations also give a true answer, but we should not consider that. But you can remember yesterday there was a situation where we could see that, right, in the class, right? Okay, now we will go to the example 13. Okay, we will start the example 13 in page 32, right? It says a particle is projected vertically up from point O with a speed u. The greatest height it reached by the particle is 62 bar. So they are asking to find the value of u. the total time of the particle is above. So we will assume it reaches the highest point and then falls back to the ground, right? So here it is projected vertically. So it is projected vertically up with u meters per second, and then it reaches a height, right? So we will go like this and come to a maximum height and come back. Now children, here I didn't forgot to tell now, although this the motion is shown like separately, the upward motion and the downward, this happens at the same vertical line. He goes up and comes down, right? He doesn't go like a projectile, but we separate the upward motion and the downward motion to the equation, right? So here we say 62.5. 62.5, and just see the value of u, that of course part B is us total time for which the particle is 50 meters or above O. So this is O, right? 50, they are talking about a level of 50 meters. 50 meters, right? So what they want, we will see right now how long he was there. The total time for which the particle is 50 meters or more. So that means if this fellow reaches here and here, right, if we say this is t equals 0th second, and here 15 minutes, first time he will come at t equals t1, and the maximum height we will put the 0 upward from 0, and the gravity also 9.8 meters per second square, that also will be marked, right? And if it is t1 here, if it is t equals t2 here, and we will put more things here. We say here v1, and the velocity is 0, and here again actually because of the symmetry, because of air resistance is not involved, if it went with v1, he should come with v1 downward, right? And actually he should hit the ground with u also by symmetry, right? And t1, t2, if we say t3, t equals t3 here, right? t3, and finally he comes here when t is equal to t4, right? So now we'll see actually what they want. Again part B will get the total time which the particle is 50 meters above. So now if we assume this is the 7th second and 8, 9, how long he was above 50? 7, 8, 9, that means 2 seconds he was in this above level. So what they want is in part B, right? What they want in part B is, right, T3 minus T1, T3 minus T1, and part A what they want is the U. So we'll see how we are going to handle this, right? Part A we will start. Part A, right? Part A they want U, right? So we can say this height also 62 points. So initial velocity v square. So here we know the height g. We can put this one. Then we should be able to find u, right? So we will put from O to where? O, we will say here A, here B, here C, and here D, right? So O to B, from O to B, we are going to put v square d equal u square plus 2as. So the final velocity is 0 square is equal to, initially is u square plus 2 into 9.8. That should be minus. I didn't mention the direction, so we will say positive direction is up, minus 9.8, and the height is 50. So u is going to be, we can take this one to the other side, 16, 19, yeah. So u square is equal to, you will get u square is equal to you will get 1225 you will get. Then u will be, right, u is equal to, right, 35 meters per second. Please you all also attempt this and see. Right, now we will see how we are going to find the T1 and T3. Right, so there is a little, special, right? We will do like this. See this, now if we put upward, right, we'll say upward, positive direction, right, if we consider s equal ut plus half at square, right, s equal ut, right, plus half at square, right, half at square, I will say positive direction, and I will say from O, right, from O. I can mention as from O to A also, but I am not going to mention that because this is a special place, right? When you put here 50 and initial, now we found 35, we can put here 35 and time, maybe, yeah, time we have to find, right, the T1 plus half 9.8 here we get a quadratic equation, right, T square quadratic equation, and there are going to be two solutions. So actually what happens is those two solutions are T1 and T3. So because of that I will handle like this, right, upward S is now 50 meters, right, upward, I can say far is from O to maybe A/B, A/C, whatever, right? This is not important, but I just mention, so for both cases we are considering, right? So 50 is equal to, and 35 we found T plus half minus, we are putting upward to minus 9.8 and T square. So here when you simplify this, right, you will get a quadratic equation as 4.9 T square, 4.9 T square minus 35T plus 50 equals 0. So from the equation when you get it, right, you will get two answers, right? One is we can say, then we have to consider this now. Two values, no, T1 is we can first we will say T, right, I will list this. So T is equal to 5.186 something, right, seconds, and or we get T is equal to 3.194. T is equal to 1.97 something, right? Therefore we can decide, right, 2SF, right, T1 is equal to small fellow 1.97, right, 1.97, therefore then T3 is equal to 5.19. So now we took the decision that the roots gives the values of the time when they were in 50. So now our goal is to find how long they were up, so take the maximum value. So we can say therefore T3 minus T1 is equal to 5.19 minus 1.97, then the answer will come as 3.2 seconds. 3.2 seconds, and it should be there 2SL. So this is a very special interesting question. Now we'll go to the final example. After that in school we can do some exercises, right? Now next example is example 14. Now this is the example 14, right? Example 14 on page 33, right? Page 33. This is an interesting example. It says a ball A falls vertically from rest from a tower 63 meters high. So we will assume now this is the tower, right? We will say 63 meters high, and so A starts his journey here, and he starts with 0. Now gravity we can mark as 9.8 downwards meters per second square. Begins to fall. Another ball B is projected vertically up from the bottom of the tower. So here bottom of the tower B is projected up with what speed? 21 meters per second. 21 meters per second upward. It is going like this now, right? So t equals 0. Now if you take the A, t equals 0, he is here. Now this is same t. T equals 0, he is here, right? Both these are same. And then the bottom where they are. And the balls collide. So somehow they come, right? At some point they collide. So we will say this is A, this is B. And collision point we will say t equals t1. Both are t equals t1. And we don't know what speeds they are going to hit, right? He is going to be reduced to some value and he is going to increase, right? And they are asking find the distance of the point where the balls hit. So here what they want is, right, we will say for both it is 9.8 meters per second. So what they want is this height. We will say h. Right, h. Right. So how are we going to attempt this? How are we going to find? So we will use the S equal ut plus half at square for both. So that means t1 is going to get in S equal means distance we know. I mean you can for him you can say 63 minus h, right, time t1. Initial velocity 0, acceleration less. For him h, and also from here to here t1. Distance is distance at one, initial velocity, so everything we know. So we get two equations, right? And having h and t1, so we can make the t1 maybe subject. We'll see. After that we will see what's going to happen. So we will say x, y, z. We will put these levels. Like here we will say x, right, y, and z, right. So we will say from, right, x to y downward, right, x to y is equal ut plus half at square downward, right, positive direction. You have to say x to y for a. Now in this case actually this is very important to test and see the value. So we have to better write this, right? So how much is going? 63 minus h. That is the amount he is going downward. And initial velocity is 0. And t1, right? t1 plus half downward is 9.8. t1 square. And we get, we will leave this as it is, right? We see what to do. A. And then again, now from Z to Y, B is going that way, right? So we can say from Z to Y for B, right, is equal ut plus half at square. So I will do that here, right? So how much is going up? H, S, ut 21 T1, right? T1, 21 T1, and then plus half. Now it is upward, gravity is below, so we have to put minus 9.8 into T1 square. T1 square, right? T1 square. Okay. Now we have a situation good. T1 square, and if we just simplify a little bit, H is equal to 21 T1 minus 4.9 T1 square. There is a easy way of simple, better we will leave as it is, this one, right? So we will make this as capital B. Now see, I saw pattern. Now here, this, if you add these two, this is plus, this is negative, that cancel off. This is not there, we will get 21, and LHS of also 60C. So we can say capital A plus capital B. So we get 63 is equal to, so H and H cancels off. 63 is equal to this square also goes off, only becomes 21 T1. So T1 is equal to 3 seconds, right? 3 seconds. But what we want is the height, right? Height. So one of the equations, so then for capital B we can substitute. Then we can say substitute T1 in B. Then we get H is equal to 21 into 3 plus half minus 9.8 both, then 3 square. So then this is a very simple simplification. Then we get 19 meters. So you all can check, this is equal to 19 meters. Right, 2SF, yeah, 2SF. No, exactly 19, right? You can check that, right? 19. So we did the examples. On Monday, I will do some difficult questions from the exercise 2F, and then we will try to finish the chapter 2, and then we will start vectors in mechanics, right? So Monday, I hope we will be able to go into vectors.